All right, here we're going to look at some statistics terminology, measures of center, spread, position. This really is going to serve as an intro. If this is interesting to you, I would recommend taking a statistics course, which we offer at St. X, and you can also take it in college. Statistics is the science of collecting, organizing, displaying, and analyzing data in order to draw conclusions and make predictions. The branch of statistics that focuses on collecting, summarizing, and displaying data is called descriptive statistics. And so what that is that's using data to help describe things. So here are some terms for us. The entire group of interest to a statistician is called population. A variable is a characteristic of a population that can assume different values called data. Data that can only include one variable is called univariate data. When it's not possible to obtain data about every member of a population, a representative sample or subset of the population is selected. So all of this is important to know because when you're hearing statistics on the news or reading about them in an article, understanding terms such as univariate data or sample can be really important because population is everyone, but as it said, sometimes you can't reach everyone. An example of this would be if I wanted to survey what people's favorite lunch options are at St. X, but I didn't want to do everyone, I could maybe just pick one of the lunches as a sample size and then assume that, since there's several hundred students in that lunch, that it's a valid sample size of the overall population. And I wouldn't really expect, D period lunch to differ that much different than F period in terms of what food is most popular, especially due to our rotating schedule. So that would be a sample that you could probably trust pretty accurately, just picking one of the lunches. Now, another sample example could be to ask only the freshmen, but that wouldn't be as reliable of a sample because they have different tastes than sophomores, juniors, and seniors who have been at the school longer. So knowing that what sample means can help you understand a survey, because if someone told you that they asked all the freshmen what the favorite lunch items were, you would know, hey, whatever this study says, I might not want to trust it because it's not a good sample. Univariate data is often summarized using a single number to represent what is average or typical. So measures of average are also called measures of center or central tendency. The most common measures of center are mean, median, and mode, and you've probably heard these before and are loosely familiar with how to find them and calculate them. And this is the same thing twice, so we're going to move on past. So here's the definition, and we'll only spend a little bit of time on these because we've worked with these in the past and we're more familiar. So the mean, or sometimes what you'll know as average, is the sum of the values in a set of data, and this is just saying how many pieces you have. 1 pieces of data, 2 pieces of data, up to as many numbers of pieces of data as you want, divided by the total number of pieces of data. And so here is a variable that when you're in statistics, they will use to represent the mean or average. And so all it is however many pieces of data you have, you add them up together and divide by that total amount. The median is the middle value or the average of the two middle values when they are arranged in numerical order. So you have to do the average of the two middle values when you have an even set of data. If I wanted us to find the median for this set of data, there is no middle number, so you'd have to find it by taking the average of those two middle numbers. And then mode is the value or values that appear most often in a set of data. A set of data can have no mode. In order for it to have no mode, that means there's no repeats. One mode, or more than one mode, because you could have some numbers that show up twice. So if I extended this out here, put in another 10 and another 16, this would have more than one mode because 10 and 16 are tied for both showing up twice. So here's an example of us using those. The number of milligrams of sodium in a 12-ounce can of 10 different brands of regular cola are shown below, and it just wants us to find the most basic type of statistics for them, which is the average, the middle, and what shows up most often. So to find the mean, which is also shown by this symbol, X with a line on top of it, is we'd add up all the data, doesn't matter what order, because when we add, an order doesn't matter, and we divide by 10, because that's how many different sodas we're looking at. And when we do that, we get that the average is 29.5. Now, what's important to note for the mean, or the average, is that that exact number doesn't have to show up in any of these. Like if you look in all of these values, that actual number of 29.5 doesn't show up. It doesn't have to. It's just on average how much sodium is in a can of regular cola that they're looking at. Now, for the median, you do need to take the time to organize them in increasing order or decreasing, because either way the middle will still be the middle. And so for this one, since we have an even number, we need to take the middle two and find the average to find, what's the middle value of sodium amongst the tin cans. What's right there in the middle. Now notice that the average and the median aren't the exact same, and that will happen sometimes. Sometimes they might be the exact same, and sometimes they'll be different or wildly different. It just depends on the types of data that you have. And when you're looking through a statistics course, you'll learn what type of data greatly impacts a difference between the mean and the median. And then mode says the value that occurs most in the set is 35, because if you look up in there, when you arranged it in order, it makes it easier to find the mode. You'll see that 35 showed up 3 times. So that's mean, median, and mode, the most basic type of statistical work that you can do on data. And that's the one that you're probably most familiar with. Here's some stuff that starts to get more fancy that you might not have heard before. There's something called the range, and it's the difference between the greatest and least value in a set of data. Something called the variance is the mean of the squares of the deviations or differences from the mean. In the formula for population variance, and you'll see it's variable there, and you can learn all about those different names in a statistics course, is this. And it looks fancy, but remember that this symbol right here is really just the mean, or the average. So what you do is you take each score, right? Here's a score, here's a score, here's a score. You subtract the average from it and square it and divide by the total number of data points, and it will tell you the variance. Now, what the variance is going to help us do is to talk about what's called standard deviation. You'll hear standard deviation used a lot because it helps decide, how different scores are from the typical average. And all the standard deviation is, it's not a new formula, it's just the square root of the variance. So if you can find the variance and then square root it, notice that this formula is just that formula square rooted, you can find the standard deviation. And so what standard deviation is going to tell you is, for a set of data, which set of data is more different than the average score than another. This value has all sorts of statistical use. You can use it to see, typically, if you would want to trust a study or not. Because if there's a really large standard deviation, that means all the scores are a little bit wild compared to the average. While a low standard deviation tells you that everything was pretty well grouped around the average. So we're going to look at it here. 2 classes took the same midterm exam. So this is something that I run into sometimes. Two classes took the exact same midterm exam. The scores of 5 students from each class are shown. Both sets of scores have a mean of 84.2. So they both have a mean of 84.2. It says find the range, variance, and standard deviation for the sample scores from Class A. Well, the range is going to be highest, subtracting the lowest. So what I'm going to want to do is write these out in order. So I have 76, we have an 80, we have an 85, an 88, and a 92. So for the range, what we'll do is we'll do 92 minus 76. And when we do that, that'll tell us what's the difference between the highest score and lowest score. And in this case, it's equal to 16. And for a test for me, I want the range hopefully to be low, because typically someone will get 100%. And if I have a large range, say of 30, that means that the lowest score was 70, which isn't passing, and that's no fun. So this one had a range of 16. So we're going to find the variance now. And what we'll do to find the variance is we're going to type in each score, and we're going to subtract the average from it and square it, and then add it up. And then I'll show you how to do this quickly on the calculator, because as you can see, it's definitely got some work to it that makes it not super fun. So here I am subtracting the average from all of my scores and then squaring it. So from further lookings, it appears that this formula is missing a -1. I got this from the textbook, but it appears that it is missing a -1. So for us, it'd be a 5 minus 4, which is really a denominator of 4. And then when we calculate that, what we'll end up getting is a variance of 40.2. And then to find the standard deviation, we will take the square root of the 40.2, and we'll get 6.34. So the standard deviation tells us the average amount by which each individual score deviates from the mean. So we see the mean right there is 84.2. That means on average, these 5 scores are different from the mean by 6.34. Right? And so we can also do that for Class B. Now, what we're going to do for Class B is see how we can do this on the calculator. So you'll have to listen carefully, maybe rewind to hit these correct buttons. All right? So what we're going to do, and it's a button we've hit before. Here we have our calculator. We've got the arrows buttons here, right? The up, right, left, and down. There's a button right here called Stat. So what we're going to do is we're going to hit Stat, and then we're going to hit Enter, right? Because as soon as we hit Stat, it's on Edit. We're going to hit Enter. And we're going to want to type things into our L1 column. If you already have things in your L1 column from when we typed some data in a long time ago, what you want to do is you want to scroll up to L1 and push Clear, not Delete. You push Clear, and then you push the down arrow, and it should empty it out. And so then, in my L1 column, I'm going to enter in Class B's scores. And this is the way that I do it whenever I'm trying to look at your all's test data. So in L1, I'm entering in B's, which is 75, 85, 95, 98, and 68. So once you have that, what you will do is you're going to push the Stat button again. Then you're going to scroll to the right, and that's going to take you to the Calc portion. And you want option 1, which is 1 var stats. And when you hit that and go down to calculate, I think some calculators are going to be different on that. It's going to tell you a whole lot of stuff. The first one it's going to tell you is this, which is the average. And that average matches the average that they told us that it was. Right? So it should make sense that those match. Then there's some things that we don't need. And then you have this, SX, and that is our standard deviation. So the standard deviation for the second set of tests is 12. That means these scores are a little more widespread. They're not as close to the average. And you can see that that's because they have a higher score, right? That's far away from the average, as is this really low score, right? Now this one's pretty close to the average right here, but some of the other ones are further. This is a wider spread group of data. In a statistics class, you end up doing all sorts of interpretations with that standard deviations to determine, is the test valid? But there's other factors as well, such as maybe this class didn't study as much, or maybe it's a class that has a lot of really high achieving students and then some low performing students, or maybe it's just on this particular test they didn't get to study for. But the standard deviation tells you, on average, how much did all the scores differ from the average. Another thing that you can use with statistics is something called quartiles. Quartiles are 3 position measures that divide a data set arranged in ascending order into 4 groups, each containing about 25% of the data. The median marks the second quartile, so Q2 is the median, so it's going to be the middle of the data. And then there's something called lower quartile, Q1, which represents the lower half, where Q1 is the average of the lower half. And you can see if I divide this data in half, that Q1 is the middle of the lower half. Meanwhile, the upper quartile, Q3, is the middle of the upper half. So sometimes scores will be put on that to determine, where people land. Are they average? Are they less than average? Higher than average? And then you can even rank, out of the ones that are below average, they're the average of the below average people. Or you can talk about the average of the above average people. And this is quartiles. It's also commonly used with statistics. So what we're going to do is we're going to look at the number of hours that Liana worked each week for the last 12 weeks. And then there they are. It wants us to find the minimum, the lower quartile, the median, the upper quartile, and the maximum of the data set. And so what that's going to be for us is just typing it in on the calculator again. We can do it by hand, but it's going to be much easier to type it in. So go back and repeat that process of the Stat button. And then we'll type in each hour in our L1 column. And when we get that, we can then go in Stat, over to the Calc menu, and do 1 var statistics again. And it's going to tell us the stuff that we need. All right. Now, for the lower quartile, on the list of information that our calculator gives us, it's Q1, and it's 13.5. And it tells us that the minimum is 10. And then you can actually scroll down. The median, it tells us, is 17. Q3, the upper quartile, is 19.5. And the max is 21. So what we end up getting here is we get a 17. We get a 13.5. We get a 19.5, where then we have the 21. and we have the 10. So that's what you can then do, and then look at the different datas that you have to answer various questions. And what you could answer with that is, how many hours do you work on average? 17. It's like, when you're working less than 17 hours, what's the average of that amount? When you're working less than 17, 13.5. If you're working more than 17 hours a week, what's the average amount of hours that you worked that week? 19.5. And you can see that the fewest you ever worked was 10, and the most you ever worked was 21. So quartiles end up doing a lot for data sets. So here, what we're going to look at is the number of minutes each of the 22 students in a class spent working on the same algebra assignment, and we've got that data there. Now, there's something called outliers. Outliers, you may know, are values that are way large or way small and don't really fit along with the sets of data. Sometimes when I'm calculating test averages, there might be outliers. Sometimes, a lot of scores will land between 75 and 100, but maybe someone forgot about the test or who knows what, and they scored a 46. That would be an outlier because it doesn't really fit with the other scores. Now, you can just toss the word outlier around, but there actually is a statistical way of calculating if something is an outlier or not. And you do that using quartiles. So here it says, calculate the interquartile range by using a graphing calculator. So if we were to type in that data, it would tell us that our Q1 is 15 and our Q3 is 25. And then you do something called the interquartile range. And so what the interquartile range does is it helps you focus on everything in between Q1 and Q3. So the middle chunk of the data. And in this case, we get a value of 10. You use the interquartile range to find the values beyond which any outliers would be. And so here's the formula. It's Q1 minus 1.5 times the interquartile range, ours was 10, and Q3 plus 1.5 times the interquartile range, which gets us 40. And so what this tells us is that anything below a 0 is an outlier. Anything greater than 40 is an outlier. Now, obviously, we're not going to have any outliers in the negative direction because you can't spend negative time. But we can see up here in the data, there's a 65 right here. That's an outlier. And so that would be a number that you'd most likely want to kick out of the data and then maybe recalculate your quartiles or your average or things like that. So a lot of statistics is just using formulas based off data. And once you get good with the formulas, you can make a lot of important claims about statistics and data. It also really helps you understand when you're reading articles or news articles for debate purposes, understanding, what a study is saying, if the study's reliable, the average, numbers within the studies. All this can be very interesting. And if you find it that way, take a class on statistics.